Okay, freshmen, for your review, you may see a problem like this that we've been working on probably since almost the first week, except for now we have this force involved. But in case you can't read what the problem says, it says Cole, the strong man, swings a sledgehammer at a carnival game. The hammer strikes with 75 newtons, okay, and moves from 1.15 meters per second to 18.25 meters per second. What is the momentum of the hammer? And the path of travel is done in 0.32 seconds. So as we've been solving these problems throughout the course of this semester, again, we would say, okay, so you've read the problem. Next thing you should do is write down what you know. And upon doing that, as we look, we see 75 newtons we know is a force. So force equals 75 newtons. Okay? And then we look, it says the hammer moved from 1.15 meters per second to 18.25 meters per second. So we know those are both velocities because we know that acceleration is meters per second squared. So if it's starting at 1.15, we know that's an initial velocity. Okay, and then it says it moves to 18.25. That makes that a final velocity, 18.25 meters per second. Okay, so what is the momentum of the hammer? And the path of travel is done in 0.32 seconds. So that makes this a time, 0.32 seconds. So now as we look at this, we're trying to solve for the momentum, which is P, or product of the mass and the velocity, which we don't know. And we're also looking for, no, I guess that is it. Okay. So with this information, we know that we have to have a mass for this, and we do not have or are given a mass in this case, but one of the aspects that we can do is notice we do have a final velocity. So what we can do with that is, with our given information, two velocities and a time then allows us to solve for a mass. So let's go ahead and do that. The formula tells you to say that the acceleration equals your final velocity, which we wrote down in our setup as 18.25 minus 1.15 all over the time that it took, which was 0.32 seconds. So upon doing that, now we can solve for acceleration. Okay? Because again, what we need to do is find the second variable for mass, and we can't do that. But let me backtrack a little bit. Notice that we know that a force equals mass times acceleration. Okay? We have the force. We can solve for the acceleration, and then once we've done that, then we can solve for the mass, and then plug that into this formula. So with our calculator then, we take 18.25 minus 1.15, and then we want to divide that by 0.32. Then that gives us 53.44 meters per second squared. 53.44 meters per second squared. Now that we've got that second squared, we know that's an acceleration, and we take that variable, the acceleration, and put into this this equation here. We've got our acceleration, and we know the force from our setup. So we take that bit of information and say that our force, which was 75, equals our mass, which we don't know, but we did solve for our acceleration, which was, again, was 53.44 m. Okay, so now that we've got this equation here, we can solve for our mass and then plug that into our momentum formula. So we've got 70, not 75. We're going to want to divide each side by 53.44. And upon doing that, these cancel. Now we can have our mass, which is 75, divided by 53.44. Then that gives us 1.40 kilograms. 40 kilograms. So now we have our mass. Okay, so now that we have our mass, now we can take that times our final velocity from our setup, and then we can ultimately solve for our momentum, which then I'll let you figure that answer out. But what you should come up with, okay, is 25.55. So the answer to this then is the product of the momentum equals 25.55. And then again, that's kilograms dash meter over second. Okay, so that's how you go about solving that problem. And just like what we've been doing all semester long, you're going to want to write down the information that you know. Okay, then once you do that, just look at your formula sheet to see what you can solve for, because as we have found out, sometimes we need to solve for one part of an equation and then put that in a second equation to ultimately find your answer. Okay, so that does it for this problem. So let's maybe review then perhaps a momentum problem, or conservation of momentum, excuse me. Because some of this information, as you know, is ongoing. For instance, just to keep it simple, we'll just say a fullback is moving towards the line of scrimmage at, we'll say 7.18 meters per second, and has a mass of, trying to think of a good answer to put there. We'll put, we'll say 98 kilograms. Okay. A collision occurs with a linebacker Okay, so as this collision occurs with, I don't think you can see that very well, occurs with this linebacker that is moving also towards the line of scrimmage. Well, he's a linebacker, so he's probably not moving quite as fast because got a slower start. So we're going to say, we'll just say 5.89 meters per second, and has a mass of, say, 115 kilograms. What is the conservation of momentum? Okay, so upon doing that, notice sometimes it's best to maybe write out a little diagram of what we see happening. So here's your line of scrimmage. So you got this fullback moving in this direction that has a mass of 98 kilograms and has a velocity of 7.18 meters per second. Okay, so that is occurring with a linebacker moving towards the line of scrimmage that has a mass of, see, this is why you always want to get that set up so you don't have to keep looking back and forth. But in order to get that done, you still need to find your correct variables. 115 kilograms and then a velocity of 5.89 meters per second. So again, what we're solving for is the momentum in both cases. So our momentum here, we don't know. Our momentum here, we don't know. So, just like what we've been doing for the last, I'd say about month or so, is that we know that your momentum, or P, the product of the momentum, equals mass times the final velocity. Well, here we're only given one velocity anyway. So again, what we would do is do what the formula tells you to do and take your mass times your velocity. And in this case, for the fullback, we get 98 times 7.18. Okay, that gives us 703. We'll just keep it simple like that, 703.64, but we'll just do this for practical purposes. And that's kilograms dash meters per second. So if we multiply these two numbers, we're going to do the same thing here. So that would be 115 times 5.89, and it gives us 677. Okay. So now we need to solve for the conservation of momentum. Just keep in mind, even though the fullback is a little bit smaller than the linebacker, he's moving quite a bit faster towards that line of scrimmage. So then this mass movement at this velocity just may move that linebacker out of the way. So our conservation of momentum means we need to take these two answers and subtract them. So we take 703 minus 677. That gives us an answer of 26. So we took 703 minus 677. That gave us an answer of 26 kilograms dash meter over second. So then what that means is we got this much of the fullback moving towards, or no, say in the linebacker's path of travel. Moving in the linebacker's path of travel. Okay. But the big thing is solving for these momentums and just make sure that once you find them, you subtract them. That's what the conservation is. Okay. So just keep in mind that you have an exam over part 2 is on Monday, this problem solving. Okay. So we wanted to give you a chance to review, because tomorrow you have an exam over part 1, which then again is multiple choice questions and your vocab that was handed back to you. And one of the things I wanted to make sure I mentioned was on that worksheet, there was a question that had dealt with, you got this circle here, okay? And what it was showing is that if there was, just picture someone doing perhaps a hammer throw at the Olympics, where what they're doing is moving in a direction of travel, and once they let that go, that hammer is going to be moving in a specific direction. But I think what it had said was, for instance, there's something attached here, it's moving in this direction, and if it lets go, at, I want to say it was like point A right there, okay? So because of the centripetal force, even though it's letting go here and moving in this direction, you might think that it's moving that way, but that centripetal force is not going to allow it to go that way. It's going to be moving that way. So just something very simple I wanted to point out. So take advantage of those opportunities then. Okay, so finally, another chance to take advantage of some opportunities is some bonus questions. And with that, okay. Okay, so for instance, we'll say bonus one. Okay, and we'll go with, I'm trying to think of one, and I think we'll go with having concert tickets. Concert tickets to the boss. That's just a common name for him. Okay. You would be going to see blank. Okay. So from 80s, little 80s music, a lot of some 90s, but mainly with that of the 1980s. The nickname of this guy was the Boss. Okay, so then also we'll go with bonus number two. Okay, just say something like go with a cliche, and that is perhaps you could, when you see two people together, you might say birds of a feather do what? Okay? So for instance, that's just one of them cliches. You might say, well, look before you leap. In other words, look both directions before you cross the road. But in this case, when you see two people, we say birds of a feather do what? And then finally, should you choose to do that, again, this is optional. It's up to you, but take advantage of these free points. So again, multiple choice questions, vocab, tomorrow, problem solving, like those two problems that we had gone over. Just keep in mind, you may solve for initial velocities. That is possible. So you were instructed to watch this video, and now you got your bonus questions. So see you and be ready to go on Friday and Monday. See you tomorrow.